In this video, we will delve into the fascinating world of AI models, venturing beyond the realm of language. Imagine a world where machines can not only understand our language, but also see, hear, and even write code. Today, we'll explore other AI models that act like specialized senses and tools, expanding the reach and applications of artificial intelligence. Let us get started. We will explore three powerful categories of AI models: vision models, speech and audio models, and code models. Each category possesses unique capabilities that are revolutionizing various fields. By the end of this video, you will gain a deeper appreciation for the diverse applications of AI and its potential to shape the future. While language models are making waves, AI's capabilities extend far beyond words. Let's delve into the fascinating world of other AI models, where machines can perceive the world visually and orally, and even understand and manipulate code. Therefore, we have categorized these models into three kinds. Let's start with first one, that is vision models, which are AI systems trained on massive datasets of images and videos. Then we have speech and audio models, which are AI systems trained on vast amounts of speech and audio data. And, lastly, what are code models? They are AI systems trained on massive amounts of code repositories. Now, let us know about each type of AI models in detail. Let us first discuss vision models. These models act as AI eyes, enabling them to perceive and interpret the visual world. These models are trained on vast collections of images and videos, allowing them to recognize objects, scenes, and activities with remarkable accuracy. Their capabilities extend to object detection, pinpointing specific objects within an image, and image classification, sorting images into predefined categories. Vision models can even perform image segmentation, meticulously dividing an image into segments with corresponding labels. From self-driving cars to medical diagnosis, vision models are transforming how we interact with and understand the visual world. And on the screen, you can read the different capabilities of vision models. This slide now includes some specific examples of popular vision models, categorized by their focus on images or videos. Image models, DALL-E, Stable Diffusion, Midjourney, and Imagen are all examples of powerful image generation models. They can create realistic and creative images based on text descriptions. Clip by OpenAI, this model delves deeper, learning the relationship between text and images. It can be used for tasks like retrieving images based on a text description or generating captions for images. Video models, Runway Gen 2, OpenAI Sora, Meta Emu, and Google Lumiere represent advancements in video generation. These models can create realistic videos from text descriptions or even manipulate existing videos. Here are some of the applications of vision models in various sectors. In the realm of self-driving cars, vision models are crucial for perceiving the environment, recognizing objects like pedestrians and traffic lights, and navigating roads safely. Facial recognition technology, powered by vision models, is used for security purposes and even personalizes user experiences. In the medical field, vision models are assisting doctors by analyzing medical scans for diseases like cancer, leading to faster and more accurate diagnoses. The world of entertainment is also embracing vision models, with augmented reality applications that overlay digital elements onto the real world, creating immersive experiences for users. Next, we have speech and audio models. These models bridge the gap between humans and machines through the power of sound. These models are trained on massive datasets of speech and audio recordings, enabling them to perform various tasks. Speech recognition allows us to interact with devices using our voice, while speaker identification can recognize who's speaking. Speech synthesis creates realistic-sounding voices for virtual assistants and chatbots. Audio classification goes beyond speech, allowing AI to categorize sounds like music genres or identify anomalies in industrial machinery. On the screen, you can see some of the capabilities of speech and audio models. This slide now highlights some well-known speech and audio models. For speech recognition, we have DeepSpeech by Mozilla, which is a popular open-source speech recognition model known for its accuracy and efficiency. And for music generation, we have OpenAI's Jukebox, which is also a remarkable model that can generate music in various styles, from classical to hip-hop. It can even create new musical pieces based on user prompts. Here are some of the applications of speech and audio models. Speech and audio models are transforming how we interact with technology. Smart speakers allow us to control our homes with voice commands, making our lives more convenient. Virtual assistants like Siri or Alexa provide information and complete tasks based on spoken instructions, acting as helpful companions in our daily lives. Customer service is also being revolutionized by speech and audio models. Chatbots powered by these models can engage in conversations with customers, answer their questions, resolve issues, and even personalize the customer experience. These chatbots can understand spoken language and respond in a natural way, offering 24/7 support and reducing wait times for customers. Next, in line, we have code models that are transforming the world of software development. These models are trained on vast collections of code, enabling them to understand programming languages and perform various tasks. Code generation allows developers to create code based on natural language descriptions, saving time and effort. Code completion acts like an intelligent assistant, suggesting the next line of code based on the context. Bug detection empowers code models to identify potential errors, improving code quality. Code translation breaks down language barriers, allowing developers to translate code from one programming language to another. This slide clearly highlights the capabilities of code models. Now this slide showcases some leading code models. OpenAI Codex. This powerful model can generate code from natural language descriptions, translate code between languages, and answer programming questions. AlphaCode by Google DeepMind. AlphaCode pushes the boundaries of code generation, capable of solving complex coding problems and even competing in coding competitions. CodeLlama by Meta. Meta's CodeLlama focuses on code generation and can create code from natural language descriptions or even translate code comments into working code. CodeBERT by Microsoft and Hugging Face. This collaborative model excels at understanding the nuances of code and can be used for tasks like code search and code recommendation. And next, we will see the applications of code models. The applications of code models are vast and constantly evolving, but here are some of the key areas where they are making a significant impact. Increase developer productivity. Code completion. Code models can help in completing the code, helping developers write code faster and with fewer errors. Code generation. For repetitive tasks or boilerplate code, code models can generate the basic structure, freeing developers to focus on the more creative aspects of programming. Bug detection. Code models can analyze code and identify potential errors or bugs before they cause problems. This helps developers write cleaner and more reliable code. Improved software quality. Static code analysis. Code models can be used to perform static code analysis, which involves examining code without actually running it. This can help identify potential security vulnerabilities, coding style violations, and other issues. Test case generation. Generating comprehensive test cases can be a time-consuming task. Code models can assist by automatically generating test cases based on the code itself, ensuring thorough testing. Lowering the barrier to entry. AI-powered programming tools. Code models can be integrated into development tools, creating user-friendly interfaces that allow even those with less programming experience to create basic applications. Automating repetitive tasks. Many programming tasks are repetitive and time-consuming. Code models can automate these tasks, freeing up developers to focus on more complex problems. Now, let's check your understanding based on the concepts covered in the video. First question is, which of the following tasks is not typically performed by vision models? You can hit the pause button and try answering it on your own. The correct answer is option C, speech recognition, converting spoken language to text. Next question is, what is a potential advantage of code generation offered by code models? You can hit the pause button and try answering it on your own. The correct answer is option B. It can shorten development time by generating repetitive code structures. As we explore the capabilities of vision models, speech and audio models, and code models, we open doors to exciting possibilities across diverse fields. The future of AI is one of collaboration, where humans and machines work together to leverage their unique strengths and create a brighter future for all. And that's it for this video. Thank you.